In this video, I'm going to show you how to develop an initial feasible solution for transportation problems using the three methods: the northwest corner rule, the least cost method, and the Vogel's approximation method. Once the data has been arranged in a tabular form such as this, which we call a transportation tableau, we can now start setting up the initial feasible solution. First, we're going to use the northwest corner rule. It is called a northwest corner rule because we're going to start on the upper left corner of the tableau, which is this corner. So the tableau has three sources and three destinations. The algorithm follows three simple steps starting on the upper left cell. Number 1, exhaust the supply, or in this case, factory capacities of each row before moving down to the next row. Number 2, exhaust the demand or requirements of each column or each destination before moving to the next. Number 3, check that all supply and demands are met. Starting on this cell, which involves factory 1 and warehouse 1, the capacity of factory 1 is 100 units and the demand of warehouse 1 is 300 units. So we can allocate 100 units on this cell. So the capacity of factory 1 has been exhausted and the requirement of warehouse 1 has been reduced to 200 units. Our option is to move to the right to the next warehouse or to move down on the second factory. But since the capacity of factory 1 has been exhausted, our option is to go down. The remaining demand of warehouse 1 is 200 units. Factory 2 has 300 units capacity, so we can allocate 200 units on this cell, which will fully satisfy the requirement of warehouse 1. And the capacity of factory 2 will be reduced to 100 units. Our next option is going to the right since the demand of warehouse 1 is equal to 0. The remaining capacity of factory 2 is 100 units and the demand of warehouse 2 is 200 units. So we can allocate 100 units on this cell. So capacity of factory 2 will be equal to 0 and the requirement of warehouse 2 will be equal to 100. Again, capacity of factory 2 has been exhausted. Our option is to move down towards factory 3 to satisfy the remaining demand of warehouse 2. Factory 3 has 300 units, so we can allocate 100 units on this cell to satisfy the remaining requirement of warehouse 2, and supply of factory 3 will be equal to 200. The third warehouse has a demand of 200 units, which is equal to the remaining capacity of factory 3. So on this cell, we're going to allocate 200 units. Demand of warehouse 3 will be equal to 0 and the capacity of factory 3 will be equal to 0. The total cost in using this algorithm will give us 5 times 100 plus 8 times 200 plus 4 times 100 plus 7 times 100 plus 5 times 200, which is equal to $4,200. This will be the starting cost using the northwest corner rule. The next method that we can use for setting up an initial feasible solution is using the least cost method. The least cost method's objective is to initially allocate supply to various destinations with the lowest possible transportation cost. So we're going to allocate units on cells with on the lowest transportation cost. Moving to the next cell with a lower transportation cost by exhausting the supply of the sources and satisfying the demand of the destinations. So using this transportation tableau, the lowest transportation cost per unit is $3. We have two cells which has $3 as a transportation cost per unit. So our option, we have two possible options. One is to allocate 100 units on this cell and another 100 units on this cell, since the total requirement of warehouse 3 is 200 units. Our second option is to allocate 200 units on this cell, since the capacity of factory 2 is 300 units. So for this case, we're going to allocate 200 units on this cell. So the demand of warehouse 3 will be equal to 0 and the capacity of warehouse 2 will be equal to 100. The next lowest transportation cost is $4 under warehouse 2 for this cell and this cell. The demand of warehouse 2 is 200 units and factory 2 has 100 units and factory 1 also have 100 units capacity, so we can allocate 100 units on each of these cells. So the demand of warehouse 2 is now satisfied and the capacities of factory 2 and factory 1 are equal to 0. So our remaining source is on factory 3 and the remaining destination is on warehouse 1, which has both 300 units supply and 300 units of demand. So we will allocate 300 units on this cell. So capacity of factory 3 is equal to 0 and the demand of warehouse 1 is equal to 0. The total cost is equal to 4 times 100 units plus 4 times 100 units plus 3 times 200 units plus 9 times 300 units. This is equal to $4,100. Most of the time, least cost method provides a lower initial cost compared to the northwest corner, on the basic idea that least cost prioritizes with lower transportation cost in allocating the units from sources to destination. The third method that we could use in setting up the initial feasible solution for transportation model is the Vogel's approximation method. This method is not as simple as the northwest corner method and least cost method, but it provides a very good initial solution. Oftentimes, it is the optimal solution. There are several steps involved in determining an initial solution using Vogel's approximation method. Step 1 is to compute for the opportunity cost in each row and each column by taking the difference of the lowest and the second lowest transportation cost. For instance, in row 1, the lowest transportation cost is 3, the second lowest transportation cost is 4, and their difference is equal to 1. Same with row 2, 4 minus 3, which is equal to 1. And on the third row, 7 minus 5 is equal to 2. On column 1, the lowest is 5 and second lowest is 8. The difference is equal to 3. For warehouse 2, the lowest and the second lowest are equal, so the difference is equal to 0. Same with warehouse 3, the lowest and second lowest are equal to 3 and the difference is equal to 0. The next step is to identify the row or column with the greatest opportunity cost or difference. For this case, the highest is 3, belonging to this column. Then, assign as many units as possible to the lowest cost cell in this column. So, the lowest cost is $5, which involves factory 1 and warehouse 1. So the demand of warehouse 1 is 300 units. The capacity of factory 1 is equal to 100 units. So we can allocate 100 units on this cell. Factory 1 will be equal to 0 and warehouse 1 equal to 200 units. Since the capacity of factory 1 is already exhausted, we can now cross out this row. Will no longer be included in the next round of computation of opportunity cost. For the next allocation, we're going to recompute the new set of opportunity cost. For row 2, the lowest is 3 and the second lowest is 4, so the difference is equal to 1. On factory 3, 7 minus 5, that's equal to 2. For warehouse 1, 5 will no longer be included, so the lowest will be 8 and the second will be 9. Their difference is equal to 1. For warehouse 2, 7 minus 4, that's equal to 3. For warehouse 3, 5 minus 3, that's equal to 2. On this new set of opportunity cost, the highest is 3, meaning the allocation will be on this column. The lowest transportation cost in this column is equal to 4, which pertaining to this cell and not on this cell because the supply of factory 1 is already equal to 0. So we're going to allocate on this cell, in which warehouse 2 has a demand of 200 units and the capacity of factory 2 is 300 units. So we can allocate 200 units on this cell. So the demand of warehouse 2 will be equal to 0 and the capacity of factory 2 will be equal to 100 units. Since the demand of warehouse 2 has been satisfied, we can now cross out this column. So the remaining rows are row 2 and row 3, and the remaining column is column 1 and column 3. Again, computing for the opportunity cost, 9 minus 8, that's equal to 1. 5 minus 3, that's equal to 2. 8 minus 3, that's equal to 5. And 9 minus 5, that's equal to 4. And the highest opportunity cost is equal to 5, which belongs to row 2. So our option is allocating on this cell and on this cell. We're going to choose the cell with the lower transportation cost, which is $3. And for this cell, factory 2 has 100 units and demand of warehouse 3 is 200 units. So we can allocate 100 units on this cell. So capacity of warehouse 2 will be equal to 0, and the requirement of warehouse 3 will be equal to 100 units. And factory 2 will be crossed out since the supply has been exhausted. So as a recap, row 1 is crossed out, row 2 is also crossed out, column 2 is also crossed out. So the remaining options that we have is to allocate on this cell and on this cell. Factory 3 has a capacity of 300 units, which will be allocated on warehouse 1 with a demand of 200 units and on warehouse 3 with 100 units of demand. So we're going to allocate 200 units here and 100 units on this cell. So the supply of factory 3 will be equal to 0. The demands of warehouse 3 and warehouse 1 will be equal to 0. The total cost using the Vogel's approximation method equal to $3,900. Again, comparing the three methods in determining the initial feasible solution for transportation model, Vogel's approximation method provides the lowest initial transportation cost and sometimes the optimal solution for the transportation problem.